So hello, starting with this second session. So still 2 minutes to go. So I'll just wait if anyone else wants to join. So as such, as I said, we don't really have a fixed agenda. So we can just simulate whatever it is that we would like. The sensible choice would be to start simulating an edge bridge converter, unless there is a better option or a better suggestion. So the only suggestion I can make is that, like we did for the Python session, rather than me programming, I would suggest that somebody else program, share your screen and program, so that we can kind of have a discussion and somebody else can get some programming experience rather than just me programming all the time.
Okay. So, sir, actually I have already done this because I was your student in Udemy course.
Mm-hmm.
So actually I have done it. So if I could show you. So can you see my screen?
Yeah, I can see.
Yeah. So actually, this is the edge bridge inverter files which I have simulated,
Mm-hmm.
and these are the typical. Actually, I have simulated for two control strategies.
Mm-hmm.
First one is this.
So just before we start, I believe I see there is one more participant. I'm not sure if this is your first time. So before, if you would like to ask any questions or if you would like to have any suggestions about how you would like to be a part of this, please do feel free to join in at any time.
Maybe he is the first time attendee.
Yeah. So you can continue with your screen share if somebody wants to.
Yeah, so actually the second person also is my friend, but he is not having access to webcam and mic, so that's why he's not able to.
Okay.
Okay. So actually I have simulated this, and I am not having any doubts as such, but I wanted to know whether there are any other more facilities that we can get out of this, because this is the output.
Mm-hmm.
So this is without the filter. So I have implemented a unidirectional PWM technique. So that's why the without filter output we can see like this.
Mm-hmm.
Okay. So basically we are getting in the output we are getting only the waveforms.
Mm-hmm.
So we are not able to get any quantified values like 230 voltage RMS or something. So is there any way by which we can do anything like that?
So first, can you show me the circuit?
Sorry. This is the circuit.
Okay. So So you have voltage source switch, okay, for bridge, and this is connected to, what is it, a load?
This is a resistive load.
Okay.
Initially I have done only for resistive load. So this is the resistive load, jump load, wire, voltmeter.
Okay. Okay. So first and foremost, like I'm assuming that of course you are using a 50 hertz frequency, fundamental frequency.
Yeah, 50 hertz frequency and 20 kilohertz switching frequency.
20 kilohertz switching frequency. Okay. So first things first, would you like to run this program and actually show me how the, for example, like one thing we can do is we can look at the switching waveform. For now, what I can suggest to you, the simplest way I can suggest to you to sort of verify what you will get is by connecting an LC filter.
Yeah, actually I have done for LC filter also, but the scopes are not, I have not saved the scopes, so that's why I am not able to show you, but I have simulated it.
Okay, sure.
So now basically we have to go to the, what is the command?
Basically, okay, so you have already gone down. Do PW, do LS or DIR. Alright, so
okay,
you are
so
now.
I need to go to that library.
Yeah.
Yeah. So
You can do DIR whenever you want to see the contents.
simulation library. Yeah, single phase full bridge inverter. Okay. So what do you want to see in this?
No. So now what I would say is, like, for example, what exactly would you like to do? Let's simulate together. That's the idea. So
okay.
For example, like your question was, you wanted to, what is it that you wanted to find out?
Actually, see, in output, after simulating, we get in output section we get scopes.
Mm-hmm.
And I mean, you get output voltage, current, or whatever you are sensing. Okay, but we get only in the form of waveforms. So what if we want to generate a report on base of whatever we are simulating, and we want to quantify the outputs? Like output is 230 volts RMS, so and so. So how do we get the quantified values of the outputs?
Okay, good idea. So let's take this as a challenge this time. Let us calculate the RMS voltage. How about that?
Okay.
Right?
Yeah, sure.
Okay. So what I would say is, let's create a new control file. Call it RMS calculator.
Okay. So so in this directory, let's say we create a new RMS calculator.py.
So now, first thing we can do is you can go to your simulator and add this new control file.
Okay.
So you can choose a new file.
Okay. This one. Okay.
Okay. You can just give it some table saying calculate RMS or something. That's okay. Because, oh, could not be there. Okay, so you have to make sure that it is in the same working directory.
Okay. So that's why it is not. It is in different file.
Yeah, everything has to be in the same working directory.
Now.
Good. So, in any control now, let's see, first and foremost with RMS calculation, how would you go about it? Let's make a plan. So, what is the RMS?
Yes, sir, continue.
No, how do you define the RMS? For example, it's best that we discuss.
So RMS formula is that I have taken out. Yes, so this is the RMS formula.
Yeah.
So
exactly.
Every sample we square it and make the sum of it, and then divide by the number of samples and take the square root of that.
Correct. So basically, we have to now do so many things. One, we have to now have we need a sum, right? Because we are taking the sum of the square of samples. Two, we need to either collect so many samples, or we need to make sure that we start at some time and stop at some time, right?
Okay.
So now let's look at what we are going to do. If we do an integration, right? Let's look at that first. Let's look at the second one or any one of them. We are doing an integration. How will we code this?
Okay.
Now, let's say, for example, what is your simulation time step?
It is 1 microsecond, I guess.
1 microsecond. So now, the main thing is, let's say, for example, if you're simulating at 1 microsecond, you want to capture every sample
of that.
Right? You are capturing every sample. You want to now create a sum over 1 microsecond, or rather over half. Let's say we can do, since we know it's a symmetrical waveform, we can do it over half a cycle. To be on the safe side, we should do over 1 cycle. So maybe first we do over 1 cycle, because so that we have a general package that we can use anytime, right?
Okay.
So what do? We need an array which will store all these values.
Okay.
Right? So first and foremost, how will you calculate this? Let's say you have 50 hertz, which means what is your time period for 1 cycle?
50 something, even by...
Yeah, it's around 20 milliseconds, right?
Yeah,
so,
20 milliseconds.
So now the main thing is, we now have to decide how many samples we need, right? Now the good thing about Python is your array is a list which can be dynamic, right? Or you can use NumPy. Either way, we can do it by both ways, right? Let's do it by the raw Python way, and then we can think about NumPy. You can try out NumPy on your own maybe. So, first thing, always with any control file, you must decide your time step, your time event, right? So, let's go back to the circuit, your simulator, and create a time event variable. So, configure control. In the other one, this is your older file. You have to go down.
Okay. Yeah.
So first thing, always time event variable. It will come down. You have to come down further. Give any value.
T1 I have used for the other simulation, so
it's a local variable. So you remember, the only thing that cannot clash is variable storage elements, because variable storage elements are global variables.
Okay.
Otherwise, all other variables are local variables. Static variables, inputs, outputs, you can reuse them as many times as you want.
Okay.
Okay, so save it. Great. So just come down, verify it's there. Okay.
Yeah,
so now we go back to our code and we can start the control block. So first you have to, as usual, you can start writing. Basically, you have to always check if the time instant t clock is greater than or equal to your time instant.
Okay.
If it's an if block, remember. Basically what you're saying is, it's like this. Imagine you're doing it in hardware. If you're doing it in hardware, you want to calculate at fixed time intervals. So therefore, you set up what is called as an interrupt. If you use DSP or something, you set up an interrupt. So every time the timer goes to 0, it issues an interrupt. Then you run an interrupt service routine.
Okay.
So this is like simulating an interrupt service routine.
Okay.
So then after this, always remember, do not forget to increment your timer. So T1 is equal to T1 plus equal to dt. You can now, it is T1 plus equal to, because it is T1 is equal to T1 plus dt, right? So now we have to define dt. So now the way to, I would say, is, in this case, since you are doing it at the same time instant as the simulation time instant, because you are calculating. See, this is not a control file. Control file means you are running control at fixed times, even signal processing. This is a computational file. So you want to run it as many times as possible, right? So what I would say, make dt to be the same as your simulation time. So you can go up and put dt is equal to 1 microsecond, if 1 microsecond is a simulation time.
Before the if statement.
Yeah, before. So these are defined at the head.
dt means this t1, huh?
No, dt is your time increment.
Okay.
So you're basically setting the sampling interval of this particular file.
Okay, yeah, just whatever the sample is there, okay. Yeah.
Okay. Okay. So now, next thing we have to do, we need to collect our samples, right? So what I would say is, let us create again, go back to the simulator and create another file variable. Here you have to add what is called a static variable, because this is a variable that needs to have memory, because you have to store this value from each state. So now choose any variable name.
So basically what we are doing is we are accumulating some values.
Exactly.
So v maybe.
Okay. So now what are we going to do? V is now a scalar, it's a 0.0 value, right? Now, we want a list, we want an array. Now, for this, there is a trick. Okay, what you should do, before that if statement, start another if statement. What you have to do, you check that if t clock is less than dt. What I'm trying to say is, if this is the first time you are running this code, right? If this is the first time you're running this code, then we run a special, no, not the full thing. The rest can remain as it is, indented. Put a colon after that and no, the other one, there. No, what I'm trying to say is the second if can come down. It's like if t clock, that can remain as it is.
Okay.
And inside the first t clock, put a colon and start the new statement.
Okay.
Now here we will redefine that variable v. V is now a scalar, right? We want to convert it to a list. So now create it a empty list. Say v is equal to empty list. Alright, so you get what I'm trying to do here. Okay, this is a trick you have to play, because in the simulator you cannot define anything other than a number. So when you want to redefine your variables as objects or lists or numpy array or anything, just use this trick. That is, if this is the first time you're running the control file, then just say that you initialize that variable to anything else. You can even use a numpy. So you can say np.array. That also is possible. Anything you want, right? So the other possibility you can do, if you don't like this t clock, is you can have a counter, right? So the counter will just say it is 0 or 1. So initially it is 0, and once you run this file, you make it 1. And after, so basically you just have to check in. If it is 0, then the control file has never been run. Once the control file runs, you make it 1. So it is like binary, true or false. That also you can do, whichever, either way will work.
Okay, so when t clock is less than dt means when at the very initial of the code, it will just create a empty what we say array,
Yeah.
and then after simulating, it will start counting the value of v and append it to the list.
Yeah, so now that is what we're going to do. So what we're going to do is, when next is if, inside the next if block, what we have to do, we have to start accumulating values, right?
Okay.
So what I will say to you is this: go back to, now we have to add an input, right? Because we need to measure a voltage.
Okay.
So now, which voltage would you like to measure?
Output voltage VO.
Yeah. So just add that.
Reload. Okay.
So you can go back. Now what you can do, you can append this latest variable to our new array.
Okay.
You know how to do it?
V dot append. Is it right?
Yeah. Yeah. Now add that. Basically, you know, right? Whatever value you add, you can give him the link. I think he's asking you. So
what you have to do now? V dot append.
yeah. See, you have now created the variable. See, go back to your simulator page. You have now created the input variable, right? So now what this means is the value, the measurement of your voltmeter is available as this variable VO.
V0.
So in the control file, if you use V0, that is the value of the voltmeter. That is the measurement of the voltmeter.
Yes.
So you can directly use that variable.
So is equal to V0?
No, append, always. Append means you have to pass that as an argument, whatever you want to append. So if you put parenthesis,
come in.
Yeah, bracket, parenthesis.
Yeah. Okay.
right?
So
So
okay. So in V list, it will append the value which is recorded as V0 in this particular sample.
right. So
Okay.
now first step is done. We have now started collecting samples.
Okay.
Correct? Now what is the next step we have to do?
Now we have to calculate using that formula, means under root of 1 by number of samples into square of each and every sample,
So
summation of each and every sample.
So now how will you do this?
So basically we have to construct that after getting each and every sample, then we will take the square of the sample.
Yeah, what I would say is try
the
to write
summation.
it down. Write your comments, try to write comments such that you create this, create the logic for this.
Okay.
And try to create it step by step so that you know, like, okay, this is what I have to do. Next, this is what I have
So first step is to calculate the square of the sample.
No, always.
And
the first step is you must collect so many variables. Right?
Okay.
So that is it. So the first thing is you must say, make sure you have one cycle of variable.
Okay.
Now, the next thing is you must know what is one cycle of variable. Right?
Okay.
So for that, what you have to do is say, calculate the length of array required. Right? Because you need to know how many.
So basically it will be the number of samples required to complete one cycle.
Right.
Okay, so the time required is 20 milliseconds, and we are recording samples after each 1 microsecond. So 20 millisecond by 1 microsecond.
Yes, that's right.
Okay.
So typically you can just say 1 by 50 because 50 is the frequency is what you put. 1 by 50 divided by 1 by dt. Right? So,
okay, so do we have to define one frequency, then we calculate using that?
What is it?
So it will be better if we define the frequency f is
exactly.
equal to 50. Then so it is a local variable, or it can be a global variable as well?
No, it can be local variable. It can be anything. So
okay.
Anyway, the reason I'm trying to do this is I would like to sort of help you create the logic. That's all.
Okay.
So now, whenever you're defining constants like f is equal to 50, always put it at the head of the file.
Okay.
Because whatever is the head of the file is guaranteed to be executed. The rest will execute only if the if block is true.
Okay.
Right? Okay. So now that you have f is equal to 50, now what you have to say is you have to define the maximum length of the array required, which is one cycle.
Yeah.
So go ahead.
So let's say time is equal to 1 by f. Okay. Then
I think it just did auto completion. That's okay.
Yeah.
Just say escape.
Okay. Okay. Then now t by dt. So that in that way we can get.
Now again, dt is above, so you have to bring dt above because otherwise it will give an error because you have dt is below. Okay. A variable always must be defined before you use it.
So we can call this as length.
Okay. Do not use variables like length because it can be, there is a chance that it can be a reserved word. So always say length of cycle, something like that. Yeah. So now we have the length of the array that we want to collect, right? So what we are going to do is, what next step? Okay, so now continue with the algorithm.
Yeah.
No, after that, first step, you've written the first command, calculate
Yeah,
length. Now what will you make?
Calculate. Okay, now we have the length of the cycle. We have calculated the length. So now we have to
basically you need a loop, right?
Loop.
Yeah. So now
for dt.
Yeah.
Yes. For
okay, now you have to put an indent because you have to be within the outside if block.
yeah. So second if block you need to be inside.
Yeah. So now there is one problem. Okay, write it and then I'll tell you. Go ahead, because we'll talk about what can be the errors also.
Okay, so basically for every dt we collect the sample and append it in the v block.
Yeah, you have already done.
Calculate the length of the array. We have done it. Okay, so it is there already. So what is the next step? We need to take the samples now.
Yes.
For dt in.
Okay, now you have already used the variable dt, so do not use it again. Otherwise, you will override that value.
No,
so,
I am using dt because for every increment in dt. So
that is not how Python works. Remember, right? In Python, if you say for x in y, it means you are picking out every element of the array y and taking it as x.
Okay.
Right? So what I can say, you can call it something like v sample.
Or v sample. Now what is the y?
You can always Google if you want to. If you need any help with Python commands, do not think about Googling. Just Google. Always Google.
So should we take T1, because now every T1 cycle we will have to take the samples, right?
So it's like this. Go back to that Wikipedia page, and we'll discuss how we're going to do this.
Yeah.
So you see, let's say any of them. Let's say the first this thing. Now we are calculating different samples in an array, right? So now you have to loop through these samples, pick out a sample, square it, add it to a sum.
Okay.
Right?
Okay. So now for first sample it will be v1, whatever it may be. Then we will square it in the next, and then we will. So first, I think first we have to be ready with all the samples, and we can do summation and square. Like I am thinking it that way. So if we collect the samples in one cycle, then we have the set of the samples we have. Then we can do anything with the set.
So now that's the thing. This is the difference between offline processing and real-time processing. You are now doing real-time processing. So the samples are coming always to you. Right? Okay. It is not that the samples are stored and you are processing it. The samples are coming to you as you are running a simulation. Right? So you have to now change your mental, because this becomes like real-time processing, real-time control. Right? So what exactly is happening? Try to think. You are running a simulation and you are collecting samples. Right? Okay. Now you need to collect, let's say you are at some instant of time. Right? You have to collect samples for a certain window, right? Okay. And for this window, you have to now perform your sum of squares.
Okay.
And you have to move this window accordingly, right?
Okay.
So there's two ways to do this. First is you can append values to the voltage variable that we did. That's one way. And you can check if you have this number of values that you need. Okay, and when you have taken your maximum value, then you start squaring. That is one. The second method is, instead of initializing your voltage array to empty, initialize it to zeros of the same length.
Zeros of the same length.
So you know how many you want for one cycle, right? One cycle of 50 hertz.
We have calculated that.
Already calculated. So you just create an array of all zeros.
Okay.
And as and how you go, you fill them up.
Okay.
Okay. So go ahead, ask me any doubt, otherwise you can code.
So actually, I'm not able to understand what will be the y. Means for x is we have defined something in the sample. Okay, but what will be the y? I'm not able to understand.
Y is the array. See, it's like this. In Python, what you need to do is, do you have Jupyter Notebook?
Yeah.
You can just try out some.
But now.
Oh no, just open a new one. You can open a new one.
Okay, for that I will have to go outside the simulator.
No, actually, no, I'll show you what. Go to the Anaconda prompt, go to the header. No, in the same window, go to the header of that. Yeah, and the left, go to the left where it is, and just right click. No, go up to where that box is, to the header. No. The header of that window, go to the header and do right click.
Okay, yeah.
Now, you will see, is there a new? Go to the leftmost on the icon. Actually, I don't use Windows, so I don't know. Go to the leftmost where that icon is. Yeah. So here, do you see a new? No new.
Move size, minimize, edit.
Okay, then actually in that case, go back to, just go to your start menu and start a new one.
Maybe I can go in Colab. So
that's also fine. Whichever. We just need a basic notebook, no problem.
Where is the new option?
You have a new notebook, see below, and the bottom of the window.
Okay. Yeah. Yeah.
So, create like some array, like 1, 2, 3, 4, 5. Shift enter. Okay. So now supposing I want to run a for loop on this, how will you do it?
Okay, for x in A.
Go ahead, right, and just print it out, or just print A into whatever is the each element multiplied by 2.
Yeah. For x in A. Sorry. For x in A. Print A.
Actually, it is better to print the element, because then it's printing the entire thing. So that's the thing. You have to, when you say for x in A, you are iterating through each and every element of A, and that particular element that you are currently at is available as the variable x. So if you print x, you will see.
So it will take one value at a time.
Exactly. So now, if we go back to our own example, if we loop through the voltage example, then we will be able to pick out every sample of the voltage for one cycle. Okay, so first two changes need to be. First, you have to change V from an empty list to a list that is zeros of that many length.
Okay, so there is a function in NumPy. There is a function, I think so.
Yeah, NumPy. Exactly. So you can go ahead. You can use NumPy because you can just import. You'll have to import NumPy. So on top, you have to just say. So now this is where NumPy becomes more useful because these functions are there.
Yes.
Okay.
So where were we?
V. The first one.
Yeah, here. Okay, so V is equal to np dot 0 of length of this length of cycle, right?
Mm-hmm. So there's no need for length. You have to just use that variable.
Okay.
Also, zeros, it is zeros, not zero.
Okay.
And you have to use curly, you have to use the parentheses, not the square brackets, because now you are calling a function.
Okay.
Right?
No. Okay.
So now.
So basically, we have created an array of all the values of zeros with length of this cycle. So now we will be taking a zero and rewriting it with the sample that we have created.
Exactly.
That we have sampled. Okay,
right.
And this we are doing because we want number of samples in the formula because 1 by n we require.
Right.
Am I correct?
Yes.
Okay.
So now, what have we now, instead of appending, the next step, we were doing V append V0 because we were just appending. Now we cannot append, we have to equate a value of the variable into that. So now the question is, there are two ways to do this. Okay, you are taking a window, you can either move samples in from the left or from the right. Alright, so like for example, what happens is you can say that the 0th sample is your latest, or you can say the nth sample is your latest. So choose whichever you want.
0th we will take.
That's it.
Okay, latest will be okay. So we will take n1.
Okay, that's also
so
fine.
We'll move from left side.
Yeah.
Okay.
So you have to give that index.
V dot, what is that?
No, again, you have to basically, okay, now go back to Colab. I will show in Colab. Because these little things are easy in Colab. So first you can just import NumPy. Okay, now create a variable. Let's say, actually you can take the variable A and just cast it as this thing. You can just call it B. You can just call it B. And take the variable A above, just say np.array of A, because you already have it.
Okay.
So now check B. Check what B is. So this is your array. So now, if you want the last element, how do you do it?
So 0, 1, 2, 3, 4. So it will be B of 4.
Okay. Now that is a hard-coded way, right? Really speaking, you should never use that. There are two ways to do it. One, check for the length of the array. So look, if you look at B, type B dot, actually capital B. Now you can type length. It will automatically, if you start typing len, it will automatically, and type tab.
No, it is not.
No?
I think it is length bracket B.
Oh, okay, because it is that way. Okay, B dot size, sorry, because it is NumPy. You can do length of B or you can do B dot size.
Length of B is equal to 5. So basically length of B minus 1 we have to take to take the nth value.
Right. That is one. The other trick is you can say b square bracket minus 1.
B square bracket minus 1. Yeah. So it will be taking the last.
You're going from behind. Yeah. So check it once and you can do. Yeah. So now let's go back to our code and add that.
So we will have to take length of B, right?
No, you can do b minus 1 is the best because it is also a well established Python.
No, but b minus 1 is, it will take the last value of the array. No? It will not show the length of the array.
No, you don't need the length because you want to only equate the final element with the new value.
Okay.
That's it.
Okay. But every time it will be equating the last value, so it will be overwriting.
That's the thing. So next thing we have to do after that, we have to do a shift.
Okay.
So first we can add it.
Minus 1.
Yeah. And now you can equate it to the VO, which is the value which is the measured input, right?
Okay.
So you are now feeding the input voltage to the last sample, right?
Okay.
Now you can come, what you can do is, you can check, you can just see for V sample, now you have to equate. Now, since you are using NumPy, right?
Okay.
Check if there is a sum of squares. Now, what you can do instead is, you want to do a sum of squares, right?
Okay.
Now, in NumPy, there is a sum value automatically. So you can just say sum and it will give you the sum of the array.
Yes.
So instead of putting VO to the last element, you can directly put VO into, that is VO square, VO into VO. Because anyway you're calculating the sum of squares. So you're only interested in the square. So instead of saying VO, you can say VO multiplied by VO.
Okay.
Because you're calculating RMS. If you wanted this to be a general function, you want to do average, you want to do square, everything, then you have to take the actual value.
Okay.
Right? Okay. But since we know what we want, we can quickly accelerate it. So now the advantage is, because it's a NumPy array, you can use the sum method.
Okay.
So you already have the square. If you say sum, you have the sum of the squares.
Sum bracket VO into VO.
Now come down and write another one. Write another variable. Now here there is one suggestion which I would give. If it is not a very trivial variable or it is not a constant, declare it as a static variable so that its value always exists. So go back to the simulator, create a new static variable.
Static variable.
You can call it anything, sum of squares or whatever.
Is it fine?
Yeah, anything. As long as do not put it as only sum or something. Try to create a little more so that you know what it is. And also it should not clash with other variables. If it is only sum ID, always things like sum, ID, length, avoid, because they can clash with existing variables.
Okay.
Yeah, so you can save it.
It's taking longer time as usual.
I think your computer is generally busy, particularly if you run Google Colab.
Yeah. Till then we can edit here.
Yeah, you can continue editing. So,
okay, so
you can just use that variable and equate it to
sum square.
If in doubt, go back to Google Colab and just try out this command. So b.sum, for example. Now this is the Python command. This is not the NumPy command. Right? When you have an array, the array is an object. The object has methods. So when you say b.sum, that is the method in the object.
This way.
And just call it as a function because it's a method. No, you have to call in after sum. You have to put a empty bracket. Yeah. So now if you press enter, you get the same thing. This is much faster than using sum because this is the NumPy method.
Okay.
Okay. So now you know what to do.
Yeah. Okay.
Basically, it's just a question of speed. They all will work, but this is the fastest way because this is an object and this is a method within the object.
Is correct?
Yep.
Okay.
So now you have calculated the square of sum. The next step is you have to do the division.
You have to shift.
No, you have to do the division because first you have to do the division, and this division is the current RMS value. Right? After you calculate the RMS value, before you get the next sample, you have to do shifting.
Okay, so we have to divide it by number of samples.
Exactly. So now this is your final RMS value. So for that, you just have to say that this is whatever. It can be a variable storage element. It can be anything because you want to plot it, right?
Okay. So it will be in this if loop itself, right?
Yeah. It will be in the if loop itself.
Okay. So VORMS is equal to sum SQ divided by length cycle. Right?
Right.
Okay.
Yeah. So this is your RMS
So
value.
do we have to define VORMS?
Yes. So that's the thing. So now you need to plot this. No, you need to plot it, right? Because this is something you want to plot. So define it as a variable storage element. Is something wrong? Check your command. Check the command line. See if any error is there. You have to come down. I think it's too. You come to the top. Has your computer hung or something?
Should I stop this?
Yeah, I think maybe stop and try it again. Because this should take just like a second.
Yeah, it has never taken so long before. Should I stop this collab?
Yeah, maybe, since we are done. No, collab is usually something which is... Which browser are you using?
It is actually Edge.
Sometime Edge. Okay. Yeah, I usually avoid using Edge. I would use Google Chrome to be safe side. Okay, what you can do if you want is you can just stop this, shut down the server, restart, and just relaunch it. That is possible. Maybe it is just something has happened. Just type enter, see if any error comes suddenly. There's something happened.
Okay.
Yeah, so just abort this to Control C and just run it again. No, you have to do, you can go up. It's just that command must be there. If you do the up command, type your up arrow, yeah, that's it.
I will open it in some different browser.
Yeah. It's okay, you can just continue for now because it's just about to finish. The first file.
It is there. It is saved.
Oh, it just got harmed. You can delete one of them. Okay. Now, if you come all the way down, we need a variable storage. No, we need a variable storage element because we decided to plot it, right? So here, I would suggest go to your control file and copy that variable here.
View RMS.
Yeah. Zero. Yeah. And storage status you have to change. Yes. Because you want to store it. Right? So now click on save. Yeah, that was fast. So now now that we are done with this, now the last step is remaining. That is, we want to now shift it. Right? So think about tell me, how would you think of doing this?
There is a shift command, I think so.
Okay, check it out. You can Google if you want.
Shift here to left.
Yeah, you can shift left because it is, the error is coming. Actually, it is better to do NumPy because now you have NumPy.
Mm-hmm. Yes, sir. So there is an
Okay, come down and see what the answer is. So NumPy is NP. So you see what has happened here? The person is saying you can do a shift, but here the shift is to the right.
okay.
Right? So what I would say, go to your Google Colab and do you have, check out Google Colab. Oh, you closed it out, right? Okay, so here what we can do, we just have to now copy the scipy command. If you go to Google this thing, go to the Stack Overflow post, there was a scipy command. See, from scipy nd image. So copy that. Actually, you can copy both, import numpy as np and this thing, because even that would have shut down. Yeah, shift enter. So now you have, okay, let's hope it runs. Yeah, so now you have them, right? So what I would say is try it out with your array B. So now go back to the Stack Overflow post and copy that. So you see shift X, say shift X1. No, actually you don't need that, only that one. Yeah, copy the full thing. Copy that full command and come to your collab array. Now only XS you have to change, because that you have to put your own variable. And you can change 3 to 1 because you only want to shift by 1. Now here it is B, not B, because your array is called. So just try it out, we'll see what happens. So check what B is above and check what B is now. So first B was
5.
Yeah.
So it is shifted to right, and the first value is replaced by something big value.
It is basically you see cval np nan. It has become not a number. Not a number the way Google Colab sees it is this huge number.
Okay.
So what I would suggest is, supposing you put cp instead of doing cval np.nan, supposing you put 0. Can you check what happens? Basically, this is how you play around with commands. No, you have to put cval is equal to 0. Right? You have to put cval. See, basically, you have to, the argument name has to be there. No, go back to your style. Yeah, and then just change that. Oh, you have to make, it has to be B. It cannot be XS. Alright. So you see what has happened? Now it is filling zeros.
And shifting the array by 3 because I have not changed too much.
So now go back and reset your B array and change the argument to 1 and check what happens. No, go back to the previous, go above and run that command again. B, where you are setting B. Because now your B has changed too much, right? So just run that thing again.
This again?
Yeah. Okay. So now try to run this shift B and make it 1 because you only want to shift by 1. Now try to run this command. So you see,
by 1.
Yeah. So now you see this is exactly what you want, right? Only problem is you are shifting to the right. So supposing you make -1, see what happens.
Yeah, it is again coming to me.
Now it is shifting to the, what do you call it? It is shifting to the left, and this is exactly what you want, right? Because the oldest element will go and the newest element will come.
Okay.
So we are almost out of time. I will.
Yeah.
Now we only have to. And you can just change B to V. No, there. And
VRMS.
Yeah.
VORMS.
No, V, because VORMS is a scalar.
So in the same vector V, it is taking shift operation.
Basically, what you're doing is shift of this function returns an array. You are setting this array to V, which means you are redefining V. right? So this is your algorithm. So you can delete the next for loop. There is a for loop, yeah. And now you can try to run this file simulation.
But where the outputs will be shown in a prompt?
Now that's the thing. Now you have stored your RMS as VORMS. You can now plot it.
Okay.
Right?
So again, the output will be in the form of graph only, no? So
yeah.
That's what I was trying to say. If we want a quantified output, a fixed output, this is the waveform, and the output of RMS value of the output is so and so. So how can we get that? Because my issue was that if I want to publish the document and want to specify the output is so and so, so having a waveform is okay, but we want a quantified output as well. So how do we get that?
No, but this will be a steady value. See, this value VORMS will be a constant. That's the thing. When you simulate it, you'll see it.
Okay. So now I'm saving this.
Mm-hmm.
It's already in this.
No, did you save it? I didn't see it. I thought it's still there. Check. Yeah, it has not been saved.
It's saved now?
Yeah, now it is saved. Because that blue dot will go.
Blue dot is, yeah.
So you can go. Just run it.
Okay.
Yeah. So you can go run. The run button go. Okay, now check the command line to see if there's an error. Yeah, so there is an error. So you see, float object cannot be interpreted as an integer. So what you have to do, you have to cast that as an integer. So go back to your code. Yeah, and above in NP0's int cycle, you have to say int and parenthesis. So you have to cast it as a integer.
Int.length cycle.
No, int. See, basically when you say int and parenthesis, you are casting the number as an integer. Yeah.
So this is what we want.
Yeah. So try it again. Now you have to go back and you have to stop the simulation and start it again. Okay, check again the command line. There is some problem in your machine. Shift is not defined. You know why? Because you have to import SciPy.
Yeah. We have not imported.
So now here there is another problem. Here the problem also is that you need to install SciPy in this thing. So you have to quit. Yeah, you have to copy that.
No, that is already installed. That is installed in my environment. So it is there.
Oh, okay, fine.
So it has to be imported in this file.
Yeah, so just copy paste that thing.
So we can copy that Stack Overflow.
Yeah. And delete that import thing. No, there is one import statement in the code. See the next line. Yeah. Okay, try to run it again. Okay, check again.
So it is
yes
running.
Now it is running. So now you can now add a new plot. And you can call it RMS voltage, whatever you want to call it.
RMS. So here it will be.
Save the waveform. You can just click done. That's it. You don't have to do, oh no, see, actually only once, because now another variable comes, but that's okay, because there's nothing, it's null.
It will not plot anything.
It will not plot anything, that's okay. Okay, check it out. So, the problem is, it is huge, you see. So, run it, I mean, do it again. See, let's see if it is increasing continuously or it stabilizes. No, don't stop it. Don't stop it. Yeah. Check it again.
Yeah, it is stabilizing.
It is stabilizing, but at the wrong value. So now we have to find out what is happening. So let's check out the code again. There is most likelihood there is some, what is forgotten? We didn't do square root.
Yeah, actually we have not done square root.
Yeah. So just do that and let's check.
Okay, so view RMS where
basically it's np.square root and you have to then pass the entire thing. Basically this sum square divided by length cycle has to be an argument to np.square root, sqrt.
Okay, so we have to take another variable name.
No, np.square, because you don't need that value, right? It's because VORMS is, yeah. And just copy that. Actually, you can cut copy. There is no need to.
So here only we have to.
Yeah, there is no need because that is wrong. VORMS that is not our VORMS. Yes. Okay, so you can run it again. I think now it should be okay. You'll have to stop the simulation. Always check command line. There is some problem in the operating system. This is a Python error. This is a core Python. So just stop it and start it again. I think there is some problem in the way I think operating system is not giving it resources. And then run it again. Check the command line.
Yeah, it is.
Yeah, so I think the problem, especially in Windows, is sometimes the Python does not get resources from the operating system. So now try to plot it.
Actually, in my desktop, I am using Linux, but there is no facility for webcam and mic, so I am using that.
Yeah, so you can just plot it. You come down, you just have to come down and plot. No, you have to plot, you have not plotted. No, you need to click on the plot button. It won't work without that.
You plotted.
Oh, you plotted? I didn't see.
Yeah, I plotted.
I see, okay. It was fast. So, yeah. So it's increasing, it will settle to whatever, 240 volts or something.
Yes.
Yeah, it's reaching there. Yeah, it will just take a little more time, but it's done. So yeah, so this is how you calculate RMS.
Yeah.
And it will be a steady value after that unless the voltage changes.
Yeah. So let me show you two more plots. So what I had done is basically whatever these data files they are generating while we simulate. So what I do, I take it into another, and what actually I do, I generate a CSV file out of that. Okay, so this is the setup file for unipolar control method. So these are the data sets of the simulation. Every microsecond, they are generating samples of IO and VO, because these were the only two scopes which I have used to minimize the resources. Okay, so by observation, I found out that the second column is current, and third column is VO. Okay, so I imported it as a pandas in Python, and then plotted and wrote this FFT script. This is the FFT script. I took help of the Stack Overflow as usual, and I managed some plots. Like this is the FFT analysis plot. See, this is the FFT analysis plot.
Okay.
So this I done using pandas. So basically, what I had a data set and I used pandas, and I tried to plot the FFT analysis. So I am facing one more challenge here, that I want to calculate the values. So maybe now you have showed me how to take the real time values and calculate in real time. So maybe in this week I will try to do the total harmonic distortion percentage value that typically we get in MATLAB now. When we do the FFT analysis, in the header of this like such plot, there is a TSD value, percentage, and the fundamental value, the magnitude of fundamental value. So maybe I will try to do in real time, and maybe in next week I will show you.
Sure, that's good.
So is there any other way? Like I used already ready set and using pandas to do this, but is there any real-time way that you are?
No, same thing. You just have to take, basically it's the integral. You just have to do the integral, means you're just calculating samples. Exactly the same way we did, only calculation will be different.
Okay. So here one problem is that here, so V2 square, V3 square, V4 square, it is not the sample. V2, V3, V4 is not a sample. It is the RMS value of the second harmonics, RMS value of third harmonics, RMS value of fourth harmonics. So if we want to do this, then all this, whatever we have done for fundamental, not whatever the output is. Okay. So now we have to first extract the fundamental, each and every waveform, and then take the RMS and then do the calculation, or is there any other way for that?
Yeah, that will be pretty much the way. Just check. There may be some other algorithms for FFT. Again, you have to Google. So there might be some other.
Actually, I was looking for, but the codes are very immense. I was not able to understand. So I thought.
Yeah, I mean, but otherwise, this is the method. Simplest method is that you write a loop saying that you want so many harmonics, and for each harmonic you do the calculation and then just sum all of it. So then you can decide your THD. Say you can set how much you want, like you can do 10 harmonics, 20 harmonics, whatever.
Okay. So typically we do till 15th or 20th.
Something like that. Yeah, usually.
Yeah. So we have to extract all the second order, third order, fourth order waveforms, and then take the RMS of that, and then take the square plus summation on square root of that, and divided by the fundamental of RMS.
Yeah.
So it will take more.
That's the thing. I don't think it will take a long time. Yeah, it will not be. It will be embedded loops. So you have to then, what you have to do is, for each time you have to run several loops, and each loop you have to calculate one harmonic, and you have to sum all of them to get the total THD and divide it by the fundamental. So it will be multiple loops.
Okay.
Anyway, you can try. We can look at it next week.
I will be trying, and I thought it will be there. Ready function will be there in SciPy or some packages, but I was not able to find.
Oh, okay. Let's see. I have not also checked. I just prefer to write code, but anyway, we can always check if there's something.
Okay. So next week are you there, or?
Next week also we are there. Yes, next week I'll be there. Then I'll be going on vacation. So next week will be this session's last one. Then after 3 weeks I'll be back.
Okay. And day after tomorrow that Python
is there.
class.
Yeah.
Okay. Okay. So if I am facing any problem, I will put it there in the Google group. So
Yeah.
if you have any time, then you can reply me there.
Okay, sure.
Okay. Thank you so much, sir.
Okay, sure. Thank you, and see you this Thursday or see you next Tuesday, whichever.
Yeah. I will be joining on Thursday as well.
Okay, sure. Okay then. Bye.
Okay. Thank you so much.